Okay, so we're going to talk about functions of two variables. Example, f of x y equal x squared plus y squared is a function of two variables. If z is equals f of x, y, then we've got z equals x squared plus y squared in the graph of this, which is a graph of this function in 3 dimensions. It's just a parabola, it's a quadratic surface, okay? Now, level curve for this function. F of x, y equals c, that's a constant. So x squared plus y squared equals c. In the xy plane, this is a circle of radius square root of c. So we can plot a series of circles for various values of c. So if c equals 1, we have a circle of radius 1. So here's 1 on the x-axis, and here's 1 on the y-axis. For c equals 2, well, actually I'm going to skip to c equals 4. Okay, well, if c equals 4, then x squared plus y squared equals 4. We know that's a circle of radius 2. So we come out here to 2. And we get a circle of radius 2. Now for c equals 2, the radius of the circle is square root of 2, which is about 1.4. 1.414, but on a graph like this, 1.4 is already a stretch to estimate. So that circle is going to have a radius that's a little closer to 1 than it is to 2. So I'm going to say it's going to run it through this point and this point and this point and this point. Okay. So I'm going to just kind of label on these circles. Here c equals 4. Here c equals 2. And here c equals 1. These are called level curves. You'll see why they're called level in a second. Now, we could do c equals 3. We can see that we go from c equals 1 to c equals 2, we get almost halfway to the c equals 4 curve. So the c equals 3 curve is going to have to be closer to the c equals 2 curve than it is to the c, well, okay. The distance from here to here, the distance from here to here is less than twice the distance from here to here. Okay, the distance from here to here is like 0.4. Twice that distance would be 0.8, which would put us out here. So the distance between these curves is decreasing. And we can see that by plotting the c equals 9 curve. And that just comes out to 3 units. It'll be up here. Okay. So the c equals 4 curve, the c equals 9 curve. C equals 2 curve. You barely see that, the c equals 1 curve. These curves go out in with unit radii. Okay? Radius 1, radius 2, radius 3 corresponds to c equals 1, 4, and 9, because of course the radius is square root of c. Those square roots keep getting closer and closer together if c increases by units. So if c increases from 4 to 9, we're going to have the c equals 5, 6, 7, and 8 curves in between here. We're going to have 4 curves in here, 4 circles. We have 3 circles between here and here. And the first one, after c equals 1, would be the c equals 2. It's already eaten up quite a bit of the distance between radius 1 and radius 2. So what's going to happen is, okay, the c equals 3 curve might be here. And the square root of 3, everybody knows, is 1.732 for significant figures. Everybody used to know that. It's not as important now because calculators have taken away a lot of the arithmetic that we used to have to do. So the c equals 3 curve, and I'm not getting this exactly right. And then the c equals 4 curve. So this is the c equals 2, c equals 3, c equals 4. And then c equals, I'm not going to try to draw them all. We've got to get 4 curves in here. So here's c equals 5, 6, 7, and 8. You see how they're bunching up. What's this have to do with the 3-dimensional graph of this? Okay. Well, we call these level curves because in 3 dimensions, I'll draw this a little bigger. I need a lot of room. Okay, first of all, c equals 0 is just the origin, right? Because x squared plus y squared equals 0 has only one solution, x equals 1 equals 0. So our c equals 0 curve in 3 dimensions, the c equals 0 curve for x squared plus y squared equals c on a graph of z equals x squared plus y squared. In other words, on z equals f of xy curve, so we're going to get this, okay? Then c equals 1 occurs when z equals 1. Okay, so let's just say that z equals 1 is here. And z equals 4, well, that'll be up here. So that's going to need some room. And z equals 9 is going to be this distance plus this distance. Here's 9. So I'm just going to put, I don't want to clutter up the picture too much, but okay. Now z equals 1. We can draw an auxiliary xy axis. And we're going to give this curve a radius, well, within in the plane, z equals 1. Let's just say that this is a unit distance here. We get a circle. Of radius 1. So we got the origin down here, we've got a circle of radius 1 here. Z equals 4. Now let me take squared plus y squared is 4 in this plane. And we're going to have a circle of radius 2. So this radius is 1. This radius, here's 1, here's 2. So there's 1, here's 2, here's 1, here's 2. Here's 1, here's 2, and right above this point, here's 1, here's 2. So the curve would be kind of like this, not a great looking circle. You can use your imagination and imagine a great circle, okay? If we go up to z equals 9, well, here's 2, here's 1, here's 3. Above this point right here is 2, so 3 will be out about here. Above this point we have y equals 2, so y equals 3 will be about here. And above this point we have y equals 2, so y equals 3 is about here. And now we can draw curve. Oh man, I was aiming for the wrong point. Oh, messed up my beautiful picture. What did y'all do that to me for? It's such a pretty picture. Hopefully I don't smudge too badly. I gotta see if I can hang this in the New York Museum of Art. They're not gonna let me do that anymore. Last time I tried, I had to spend 6 months in jail. So, anyhow, so we come through here, we go all the way out to here, and it's messed up. But there it is. Again, use your imagination, pretend it's really round. Okay? Okay, well, this is just a white curve here. And this is just the blue curve. This one isn't too bad. And, let's see, we made that one sick orange or whatever this color is. Okay? So we're stacking these circles. Now in this case, we know what this shape is going to be. It's going to be a paraboloid. So in any plane, any vertical plane, we cut this thing and we get a parabola. Okay, for example, if x is 0, the plane x equals 0, that's the yz plane. In the yz plane, we got points here, 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 and here. So right there, and right here. Here's where x equals 0. There's your parabola, right? Now if y equals 0, we get a parabola in the xz plane. It'll go through this point, this point, this point, and this point. And also through this point, this point, this point. Uh-oh. I messed it up again. Maybe we get to hang this in Joe's garage or something. Okay? Might get away with that if Joey's at home. Okay, so here we go. Let's fix this. Looking at the wrong point. Supposed to go through here and here and here. Except I screwed that one up too. That's supposed to be out here. We're not going to try to fix it. No, actually, it's supposed to come out like so. Maybe it will. Fairly clean cloth, so maybe it won't smudge too badly. Yeah, that's terrible. Demonstrating what you got to do to draw these things, right? So you got to see the pitfalls. And I'm getting really good at illustrating pitfalls. Okay. So, probably an even more terrible circle. But in the YZ plane, we got to go through this point, this point, this point, and this point. So, it's actually a better parabola now. In the XZ plane, the points we go through are going to be kind of close to these. We're going to go through this point and this point and this point, which is going to be really clumsy. And then back here through this point, and this point. So, you know, back here, I use dotted lines here, we come down kind of like this. Over here, we come up kind of like this, except I missed this point here, so it's not real good. Then, in any plane, we can kind of see how to draw a circle that kind of shades in this picture. It gives you the idea of a paraboloid. Okay, so we go from level curves to a reasonable graph of the function. And of course, we'll actually come out with something like this. To flesh it out a little more, and I don't want to get all into engineering graphics and stuff. When I was a freshman, we took a course in engineering graphics where we sketch curves. Okay. It's a one-credit course, but everybody took it. Okay, well there it is. I mean, every freshman, because we're at Institute of Technology, okay? So no matter what you were going into, there's a good chance you're going to have to sketch these. It was very beneficial then when we got to this course. Apparently I'm not showing any of the benefits here. This paraboloid, which is in a different plane, is still visible, so we can kind of extend this and flesh it out. Okay. So it's worth messing around and trying to sketch some of these things. I've demonstrated some of the things you do, and I did similar things with the quadratic surfaces. And this is a particularly easy one. I don't much like the pictures that you get from software, which you see all over the place. For some reason they do the job. They don't really show you how they were constructed. They don't force you to think about the level curves or the intersections with vertical planes or any of the other stuff. So you want to kind of make sure you do that yourself to really understand this picture and these pictures, because they're all related to your parallelepiped. I'm going to show you how.